Hello, my name's Lynn. I'm the voice behind the videos, so you'll be hearing me doing some explanations for your functional skills maths exam at level 2. We've got lots of different videos in the series, all on different topics. I'd suggest for each of them you make sure you have a piece of paper, a pen and a calculator handy so that you can have a go at the questions as we go through. I always suggest that you pause the videos, take as much time as you need, and then carry on and have a look at the answers with me. Do always feel free to rewind and fast forward through any video so that you can either recap or skip to a point where you need a bit more explanation. We've got videos for all of the main topics, and in each of them we'll look at some of the methods and strategies to answer the different types of questions. We'll look at the wording of the questions, and we'll look at some practice exam questions for every topic so that you can feel more confident going to the exam that you know what you need to do. So join me in our upcoming video, and good luck for all of your exams.
I'm going to take a look at ratio. Because this is actually quite a long presentation, I've decided to split it into 3 separate videos. So the first video is going to take you through the explanation of how ratio works. The second video will work through some examples. Some people think these are slightly easier examples, so we'll work through those in the second video. And the third video will work through some harder examples. So you can choose whether to watch all 3 of the videos, whether to just go through the examples for either the easier or the harder ones, or you could just watch the explanation, or you can choose any combination. So we're going to take you through the explanation part first. So we'll look at what ratio is, some of the vocabulary associated with it, how to compare ratios and fractions, because I find this often helps people to understand the topic, how to simplify ratios, how to find ratio parts, how to split an amount into a ratio, and some word problems associated with ratio. So first of all, we actually tackle what is ratio, and this is something people do struggle to define. I always found it quite difficult to explain what ratio was. One way to think of it is a way of comparing quantities. So you're comparing quantities together, and what's useful about ratio and what you can't do with a fraction is to compare 2, 3, 4 or more quantities using just a single ratio. It's used in lots of different scenarios. It's often used in recipes, and you'll see that in the exam, a lot of questions around cooking and baking. It's used when mixing things together, so that could be mixing paint, mixing concrete, mixing plaster, anything to do with all DIY ratios there. It might be used in a sort of safety form, so a ratio of students to teachers, nurses to patients. It can be used when sort of working in scale drawings, and there's a separate video all about scales and how to use ratio in that sense in terms of maps, and lots of different other scenarios. As I say, mainly on the exam they tend to use either cooking ones or sort of mixing quantities to make something like concrete are the most popular scenarios. One type of ratio is directly proportional. So a lot of the ones you'll come across on the test are directly proportional, which means that as one quantity increases or decreases, the other quantity increases or decreases by the same or in the same ratio. So by the same factor would be a better word to use. So if one quantity doubles, the other quantities automatically double as well. Indirectly or inversely proportional is all the opposite of that. So as one value increases, the other decreases at the same rate. And you're less likely to come across those on the exam. So many of the methods you use for ratios are similar to the methods you use for fractions. It would probably be a good idea if you've watched the fractions video first, because that will go through a lot of the methods we'll use for this. So let me just give you an example. 8 people are going to a meeting, 5 of them are male. So a ratio can show the parts that make up a whole. So this ratio here, using the notation of the colon, which is the standard form for using a ratio, shows the ratio of men to women. And you always see the numbers presented in the order of the words in the question. So men here on the left and then women on the right. What the ratio doesn't do is show the total amount. You could work that out yourself afterwards if you wanted to. A fraction can only show one of the two parts at once, but what the fraction shows is the whole or total amount. So the fraction can only show the part, in this case males, out of the whole, which is 8. It can't show us the other quantity, so it can't show the breakdown of the different quantities. It can only show us one part compared to the whole. So if you remember back to your lesson on fractions we always talk about part out of a whole. Whereas with ratio, we're talking about parts compared to each other. Thinking about the methodology for fractions when we simplified them, you can do the same for ratios, and often it's useful to be able to simplify a ratio to express it in its simplest form. So that means dividing all the parts within the ratio by a number they all have in common. A couple of top tips. If both the parts or all of the parts end in a 0, you can divide by 10 to remove that 0, which is just crossing the zeros off. Even numbers will always divide by 2. Odd numbers, try 5, 3 or 7. And hopefully that should cover a little bit of everything in order for you to simplify your ratios. So if we just look at the example here, we can easily simplify this one by knocking a naught off each or dividing each part by 10. That will take 100 down to 10, 400 to 40 and 50 to 5. It's always important not just to do one step, but to check if there's a further step you can do afterwards. Because all three of these numbers end in either 0 or 5, that means they're all divisible by 5. So 10 will divide down to 2, 40 will divide down to 8, and 5 will divide down to 1. Once any of the numbers has got down to 1, that means you stop. That is the simplest form of that ratio. Otherwise, you wouldn't know at what point to stop. You could just keep dividing forever. This ratio, 12 to 15 to 24, all of those numbers are divisible by 3. So if we divide each of them by 3, we get 4, 5 and 8. It's really important that you divide all of the parts by the same thing. It's no good dividing the 12 and 24 by 2 and then the 15 by 5, because you won't create the simplest form of that ratio. You'll just create something else and it'll be a horrible mess. Do you want to just have a quick go? Simplify these ratios. So there's 1, 2, 3, 4, 5, 6, 7 to do that. Pause the recording at this point, have a go, just jot down your answers, and then on the next slide we'll see what the simplest form of all these ratios is. Okay, so let's have a look at the answers. This one would simplify down to 2 to 1. This one, 3 to 1. This one is divisible by 5, so it breaks down to 9 to 13. These you can either do as even numbers and keep going, or you might spot that 6 goes into them both. Or you could even spot something a little bit further than 6. You might even say 12 goes into them both, and that will get you straight down to the final answer. 9 and 180, you might have spotted that 9 goes exactly twice into 180, therefore it's 1 to 2. Same here, 1 to 2. And this big number, because there's 6 zeros on each of them, you can knock them all off, divide them each by 1,000,000, which gives you 14 to 16, and then easily halve that to get 7 to 8. So well done if you got all of those right. Don't forget to always simplify as much as you can. So for ratio parts, this is the type of question that's most common in the exam, and you need the skills of multiplication and division for this. Generally, you don't want to try and think too much about adding or subtracting. That's where people tend to make mistakes. So here's a sample sort of question. For every 3 children in the nursery, you need to have 1 staff member. So you have a ratio of 3 to 1. 3 children, 1 staff member. So if the number of children doubles, so you've got 6 children, the number of staff would have to double, 2 staff. If the number of children from the start gets 5 times bigger, so 3 times 5 is 15, then you have to multiply the number of staff by 5 as well to make it 5 times bigger. So if you have 15 children, you need 5 staff. If we look at it from the other angle, if you have 8 staff, we want to know how many children you could have in the nursery. 1 times 8 is 8, 3 times 8 is 24, so you could have 24 children. Now, if you had 25 children one day, you could work out how many staff you need by dividing by 3, because remember, it's 3 to 1. 25 divided by 3 is 8.3. Now, in normal maths, I would tell you to round 8.3 down to 8 because we'd apply rounding rules. But in this case, we need to make sure we're always sticking to the real life scenario. Functional skills is all about real life. In real life, we'd have to round up to 9 members of staff. Because for 8 members of staff, as we saw in the last page, you can have a maximum of 24 children. So if any more children over that, we need 9 members of staff to meet the regulations. So with functional skills questions, always check that they work in real life. Don't just stick with the pure maths and forget about the scenario you're working with. Here's another example. A painter always mixes paint in the following ratio: 15 mils of blue, 10 mils of red, and 5 mils of yellow. He wants to use 30 mils of blue paint for his next painting, and he needs to know how much red and yellow paint to use. If you want to pause and write this down yourself, that's fine, otherwise we'll carry on and have a look at the answer. So what I would do in this question is write out all the amounts I want to know clearly by labelling my blue, my red and my yellow. I'd label the original ratio and I'd label anything else I know, like 30 mils here. I can then look at the relationship between the numbers that I know, the 15 and the 30. What has happened to 15 to get to 30? It's been doubled, been times by 2. Whatever I do to one part of the ratio, I have to do to the other part. So if blue doubles, red will double as well to make it 20, and yellow will double as well to make 10. So my answer will be 20 mils of red paint and 10 mils of yellow paint. So now we've done that slightly straightforward example, I want to give you the same question, but with a slightly harder bit of maths in there. So the same ratio, but this time he wants to use 240 mils of yellow paint. So we need to know how much red and blue this time. So I want you to pause here and have a go at doing this question and then carry on in a moment. Do feel free to use your calculator if you wish to, or you may want to practice doing your maths by hand without using your calculator for some of these. Okay, let's have a look at the method for this one. So this time we're looking at the relationship between the yellows, because that's the number we're given, 240 yellows. We need to know this relationship between the 5 we already have and the 240. So what has 5 been multiplied by to make 240? In the last example it was easy with the blue, we could see it had doubled. This time it's not so obvious. So if it's not obvious, use division to find your what we call multiplication factor. So 240 divided by 5 will give you the number to multiply everything by. So if we look at the final step, doing that division gave us 48. So 240 divided by 5 is 48, which means that all the parts along the top have to be multiplied by 48 to get the new numbers at the bottom. So that means we need 720 mils of blue and 480 mils of red. We can also look at it working because we know the red is double the yellow and 240 doubled is 480. So it all looks as if it should work. And actually we could even check the blue because the blue should be 15, which is 10 and 5 added. So 240 plus 480 should give us 720 if everything has worked out correctly. There's often lots of ways you can check things, and don't forget on the exam you'll often be asked to show a check, so it's good to have these checking strategies already. Here's another question, see if you can have a go at it. I'll let you read it through for yourself, and then afterwards we'll have a look at how to work it out. So don't forget to pause so you can take your time over it. So here we go. I would suggest that, again, as with all ratio questions, you write things out with headings. Don't have to write full headings. I use V and C. Just make sure I'm not mixing up my numbers. So what we know is 850 visitors was 150 cars. We're then going to use cars of 120 to predict the number of visitors. So we want to compare cars and cars here. So we want to find the relationship between the parts we know. How do we get from 150 to 120? And again, it's not an obvious one. It's not one we can say it's doubled or tripled. So to find it, find that division or multiplication factor by doing a divide. Divide 150 by 120. And that tells us that 120 was multiplied by 1.25 to get to 150. Or looking the other way, 150 has been divided by 1.25 to get to 120. It doesn't actually matter which way you think about it, so long as you apply the right working to the other side. Because we're going this way, we want to go this way and divide here. So to get our visitors, we need to divide 850 by 1.25. That means the manager could predict 680 visitors if 120 cars come through the doors. You may have done that in a different way and still got the same answer, so if you did, that's absolutely fine. I'm just showing you one possible way of working these out. Another thing you may be asked to do is share amounts in a ratio, and the key to doing those correctly is to make sure you know what the total number of parts in your ratio is at the start. Let's do a cake example. So how much mixture are you going to make altogether in this cake? All you would do is add the parts together. So 200 plus 100 plus 50, 350 grams. If we want to make 700 grams of mixture altogether, how much of each ingredient would we need? So if we find our total that we have to start with, 350, we then compare that to the total we want, 750. And in this one again, we can see it's a nice, easy calculation. We can see that it's doubled. So we just need to double each of our elements. So we double 200 to get 400, 100 to get 200, and 50 to get 100. We can also add these up to check that they give the total that we've been asked to find, so that's a good check. Apart from sharing amounts in recipes, sometimes money comes into it. So Jess and Alex have got lines on the lottery. Jess has 4, Alex has 3. They're going to split up their winnings in the same ratio. Jess will get 4 shares of the winnings and Alex will get 3 shares. So what would that look like as a ratio? Can you just jot that down? So that will look like 4 to 3. You don't have to have put the headings in. As I say, I always just like to make sure I'm doing it correctly. Remember, you need to put the 4 before the 3 because it says Jess and Alex in that order. So they win £70 one week. How much money will they get? And then they win £28,000. Very well. How much money will they each get? Do you want to pause and have a go at working that out? Let's have a look. So for the £70, you may have automatically just in your head been able to see it with 40 and 30, but the maths behind it is that we add the shares together, the 4 and the 3 parts that we had to make 7, and then we divide our total we're going to have, 70, by the total shares we currently have, 7. which gives us 10. So that 10 is the value of one part of the ratio. Jess has 4 parts, so 4 tens, 40. Alex has 3 parts, so 30. Use that same idea for the £28,000. We still have 7 parts or 7 shares in total. We divide the 28,000 between those 7 shares. So each part or each share is worth 4,000. Jess has 4 of those, so 4 4,000s is 16,000. Alex has 3 4,000s, which is 12,000. And our check is to add those two up, and it should give us the 28,000 again. So anytime you're sharing amounts, make sure you add up the existing parts first before you do any kind of division. Be careful for tricks in the wording of questions. Let's just read this one through and then have a go at expressing the ratio. Always express ratios in their simplest form, even if it's not specified in the question. It's always good practice to do so. So you should have got the answer 3 to 1. Because 150 went, so we're in advance. The rest of them, the 50, paid on the day. Simplify that down to 3 to 1. A lot of people automatically use the numbers 200 and 150 to form their ratio. So you need to make sure you read the wording of the question. Watch out for units as well. I know I'm always talking about units, but they are also important in ratio. You might have one amount that's expressed in centimetres and another in metres. You can only create a ratio when the units are the same. So just to recap what we've said, read your questions carefully. Work out what you're asked to find. Are you finding a part of a ratio? Are you creating a ratio? Or are you sharing an amount into a ratio? I suggest writing everything out clearly with headings. That is up to you, but it's just my suggestion. You want to look what the relationship is between all of the numbers. And remember, what you do to one part, do to the other. Always read the questions a couple of times to make sure you know what's happening. And then make sure you do a check to confirm that you're correct at the end. So those are my top tips. In the next video, I'm going to go through some of the slightly easier exam questions on ratio. So do make sure you have a look at that if you want to see the easier examples, or you can skip straight to the video, which is on the harder examples.